Good morning, dear children. Now today we will come to the application of Pascal's law. So last time I explained about the application of Pascal's law, that is about the hydraulic principle of hydraulic machine. Now there are various examples of hydraulic machines. One is a hydraulic press, other one is the hydraulic jack and hydraulic brake. Now today we will discuss with the hydraulic press. And this machine, it is a hydraulic press, it is a machine which is based on the Pascal's law. Now this is the diagram of the hydraulic machine or the hydraulic press, we call it as a hydraulic press. Now it consists of two hollow cylinders P and Q. These are the cylinders P and Q. Okay, fitted with two valves V1 and V2. These two cylinders are fitted or connected with the valve V1 and V2. And the cylinder P is connected, that means the base of the cylinder P is connected with the valve V1, in which this is again connected with a water supply tank or the reservoir. That means the cylinder P, the base of the cylinder P is consists of a valve V1, okay, and this cylinder is again connected or joined with a water supply tank or the reservoir. Then other one is the cylinder Q, okay, and cylinder at the base of the cylinder Q there is a release valve, we call it. This release valve means after when the machines will complete its work, then the water from this cylinder will be released by opening the valve, and the water will be again collected back to the reservoir. Okay, and now this cylinder P has got small cross-sectional area and cylinder Q has got larger cross-sectional area. And these two cylinders are again fitted with a piston A. Cylinder P has got a piston A and cylinder Q has got piston B. This is the piston B. Okay, and the cross-sectional area of piston A is smaller than the cross-sectional area of piston B. That means piston A has got a smaller cross-sectional area. Let us consider the cross-sectional area of piston A is A1. This is A1. Then cross-sectional area of piston B is A2. Okay, and A2 has got larger cross-sectional area. This has got a larger cross-sectional area, as well as the cylinder is also larger. This piston A has a cross-sectional area smaller, and this piston A and this cylinder is also smaller. Okay. Now these two cylinders are connected with a connecting pipe. These two cylinders are connected with the connecting pipe. And other one is there on the top of this, on the top of the piston. Okay, the piston B, the bale of cotton, the cotton has to be compressed. The bale of cotton are kept on the top of this piston here. And this portion, this is the fixed support here, this is the fixed reason. When when the piston will move up, this cotton get compressed. Okay, they get compressed on this support, on this fixed reason here. Now, and there is a lever here. Okay, when this piston A, and this piston is known as the pump plunger, and piston B is known as the press plunger. And to make this piston down, to move the piston down and to raise up, some lever arrangement, okay, some sort of lever arrangement is made here with the help of the handle. So this is the handle here. Okay, so and this handle is made, or the arrangement of the lever is made on this piston A in order to move the piston up and down. So to move the piston up and down, the handle is provided here. Okay, so this is the arrangement how these hydraulic press are constructed. Now what happens is that now when the handle of this pump plunger, okay, piston is known as the pump plunger. When the handle of this pump plunger is moved down, okay, when it is moved down, what will happen? The pressure is exerted in the water. Okay, the pressure is exerted the pressure is exerted by the water here, and due to high pressure here, what will happen? The water through this connecting pipe will go through the cylinder Q, and here and what will happen is that, and the pressure will be exerted here on the cylinder Q, and due to this pressure the piston B will move up and it compress the bales of cotton. Okay, so how it works is that, now since the surface, the cross section area of cylinder P is small and the cross sectional area of cylinder Q is bigger, so according to Pascal's law, when some force, when small force is applied on a smaller piston, okay, larger force, the pressure exerted on the smaller piston will be exerted towards the larger piston, and the greater force will be exerted on the larger piston in the upward direction. So that is in a hydraulic principle, hydraulic machine. I have explained that. Now what happens is that, now here this handle are moved up. First of all, this handle is moved up. When the handle is moved up, what will happen is that the pressure get decreased, and therefore what will happen, this valve will open. When the handle is moved up, when by moving the handle up, the piston A will move up. When the piston A will move up, the water from the reservoir or from the tank will move or passes into the cylinder P by opening the valve. The valve gets open here, and this valve will open when this handle of this piston is moved upward. Okay, when it is moved upward, the valve gets open, and the water from the reservoir will pass through this valve and fill it inside into this cylinder P. Then after that, what will happen is that, when now you press down the handle. Once you press down the handle, pressure is exerted in the liquid. Okay, in the water, the pressure will be exerted here. A small due to the force. That means when you press it down, the force will be exerted by this handle, and pressure is exerted in this water which is present in the cylinder P, and that pressure, through that pressure, the water will move through this connecting pipe. Okay, and in this connecting pipe, the pressure will be more than the pressure in the cylinder P, and due to that greater pressure in the cylinder in this connecting pipe, the valve V2 opens. When the valve V2 opens here, the water through this connecting pipe will enter through this cylinder Q, and therefore the upward force will be exerted here. Okay, the force will be exerted upward, and the greater pressure will also exert in this bigger cylinder, and due to that pressure and due to the upward force, this piston will move up. It will move up, and therefore the bales of cotton get compressed. Okay, so this is happening. So when the bale of cotton get compressed here, okay, then after that, after completing the work, okay, when the machine will complete the work, then what will happen, by opening this release valve, okay, now this water from this cylinder Q will pass through this release valve, and again it gets collected in the water supply tank or receiver. So that means the water doesn't get wasted here. Okay, the water will again collected in the receiver. Then again, if you want to press the bale of cotton again, you pull the water there. So in order to fill the water there, again this handle, the handle of this pump plunger or the piston A is moved up. When it moves up, the pressure decreases here, and due to decreased pressure, the valve V1 gets open, and water from this tank will enter into this valve. Through the valve, it enters into the cylinder. Then after that, when it pulls down here, then what will happen? The pressure is exerted by the liquid also, as well as the atmospheric pressure is also exerted. Because this atmospheric pressure is exerted just above the water level. Just above the water level, the atmospheric pressure will also exerted. So due to atmospheric pressure and the pressure of the liquid, okay, then this water will move through this connecting pipe, and this connecting pipe will get more pressure than the cylinder Q, and due to that greater pressure, the valve V2 will get open, and when the valve V2 will get open, the water through this connecting pipe will enter into the cylinder Q, and this water, when it enters into the cylinder Q, will create a larger pressure. Okay, larger pressure, and due to that pressure, this piston will move up, and the bales of cotton get compressed air. So this process is continuous. Then after the completion of this work of the machine, when the machine will complete its work, then again the water from this release valve will again the release valve get opened, and again the water will pass through the release valve and collected back into the receiver. So this way the hydraulic press it works. And the uses of hydraulic press. So there are various uses are there in hydraulic press. Number one is for pressing cotton bales, okay, coiled books, etc. For books binding, that means the books are also get compressed. Coiled means all the blankets, okay. So these are compressed, the cotton bales are compressed by using this machine. And other one is also there by extracting juice from the sugar cane. Okay, from the sugar cane also you extract the juice, and the sugar cane get compressed. By compressing the sugar cane, the juice will be extracted. Then the other one is also there for squeezing oil from the linseed and cotton seed. Okay, so also to extract the oil also we'll use this hydraulic press. So this is the first example of hydraulic